My guest today is Lennart Koopman, a much loved and talented figure in the cybersecurity community. He founded Graylog and devoted over a decade of his life to this open source project that has grown to be used all over the world by small startups to big enterprises. A little over a year ago, he founded a company called Nzyme and is developing some very exciting new network defense technology. On today's show, we're going to be talking about Wi-Fi security, and we're very lucky to have Lennart with us sharing his expertise. Thank you so much for being with us on the show today, Lennart.
Of course. I think y'all are producing a ton of actually valuable content that I also listen to, and had a great time at your conference last year, and I'd love to play a small role in it.
Oh, well, thank you so much. And yeah, Mission Control, that was a really wonderful conference, and I remember your talk greatly, which is why I've invited you here to talk.
I was choosing my outfit this morning and picked from my many t-shirts, and I almost accidentally wore the Mission Control t-shirt. That would have been perfect. But I did not. I forgot. I should have.
Oh, well, yeah. I think your shirt looks great. I'll just give a little shout out to my shirt here. Yeah. So the place I always like to start is with the origin story. I know you grew up in Germany and then moved to America, and that you barely made it through high school. But how did you get interested in computers, and how did that turn into a career in cybersecurity?
Yeah. It feels like it's so long ago that it's a little blurry by now. We're all old, so trying to remember our very early days gets a little blurry. But I think the first thing that comes to mind is I remember when my parents got a computer, and it was like 1994, and I was like 6 years old then, and it was the kind of a ghost like into my dad's home office, so to say, or wherever his desk was. There were no home offices back then, but it was there, and it was very controlled access. As in, I was 6 years old. I was not allowed to just be there all the time, which is what I wanted. But when you got a computer back then, you set it up, and then the big question is like, now what? Right? I remember that. I remember turning it on, and the BIOS boots up, and Windows 95. No, that must have been, what was it? The one before, like 3.1 or whatever. It's so long ago, I even forgot. Yeah. But it boots up, and you're like, now what, right? And because 1994, this thing wasn't connected to the internet yet, which would be the immediate first thing that I would have probably done. And so I was immediately drawn to trying to figure out what this thing can do for me. And then I think immediately the next question is, what can I make this thing do, right? And there were some very simple programming languages back then, and I just kind of got into that. And this was, I think, the fascinating thing that many of us experienced was when you made it do something and it did that, and it just did that, right? And now you can think about, I can make this thing do more things, and so that's really how it started for me. And it was a very early fascination, and I'm glad that my parents got that computer and also kind of trusted their instincts to just let me work with it and let me do my thing. Maybe even if the grades in school were not always perfect, maybe that could be the way out. Even if, he seems to be good with that. Let him keep on playing with that. But basically, I then moved to the next bigger city with 17, and I started working in an IT help desk, which I'm still very glad I did. I think that is an absolutely fantastic start for any career with computers. Teaches you a lot of things about people, how to deal with people who might be in a rush. It was in a hospital, and so you have nurses who have to get their job done, right? They're not there to deal with computers. They have a much more important job that is often under time pressure. And when the computer doesn't work, they can get impatient and impatient. I understand that. And you're 17 years old and have to deal with that somehow. Teaches you a lot. And I'm very glad that I did that. But I was always programming on the side, little hobby things, kind of playing around with it from very, very early on. And then that eventually became my job after the help desk time. And I actually had no real clue of InfoSec outside of kind of what you have to know to write and run secure code. And I very much just accidentally stumbled into that later. So my background has been software design, architecture, programming for really the longest time of my career.
Okay, and then cybersecurity just as a add-on effect of that.
Yeah. Absolutely. Came through. I think what we're going to talk about that next. So just as a little teaser.
Yeah. Okay. And that's really interesting. So yeah, as you just alluded to, and as I alluded to in the opening, in 2009, you decided to complicate your life and founded an open source project called Graylog. I don't think it was started initially as a cybersecurity product. Can you tell us what Graylog does and what the original intention was?
Absolutely. So back then, Graylog was simply collecting log data. Log data for me, the only thing I knew about it was that that's what your application spits out when it does things or when it didn't do things, right? That was logs for me. They're either informational or there's a problem. There are warnings, errors, fatal, something like that. And so Graylog just accepted these logs in the very first version over syslog because I had no connectors, nothing, and the application I was monitoring was sending syslog. So I just collected syslog over a network socket, parsed that, stored it in a database, which was a MySQL with like the most simple database design anyone came ever up with. I think there was a table called messages, and that had all the log messages in it. And I built a small interface over it so you could search over it, filter over it, set up simple alerts, very simple alerts. And the initial log volume was that it was considered an extreme outlier if we would see more than 100 messages in 10 minutes. I mean, it was no volume. It was tiny. But I think the key to its initial success was that it arose directly from a very real use case. And people with similar problems could just go and immediately run it. It could kind of be the ultimate form of release early and often, right? I released that thing. It all took was put syslog into a MySQL database. That's all it did. And it was 100% for developers and operations people, had absolutely no security angle at all. And you just see all the errors that your app generated, and then you could figure out what was going on. But that was something a lot of people needed. There was a company out there back then, that was 2009. There was a company back then called Splunk, and they offered similar things in much better and many more things, much more data, but they also cost a lot of money. So there was this big black hole of entirely unserved market of I just need to collect my logs so I can see what's going on. And people immediately started using it. I remember putting it on GitHub, and I think a week later, there were the first people who ran it, who had bug reports, people contributed code. And then from there on out, it just like a snowball. More and more people started using it. And I did decide to complicate my life, but I was also 21 years old and not really clear, I think, on what I was getting into, which can be good too, if you just do it.
Yeah, right. I'm curious, at what volume did you realize SQL was the wrong choice for the backend?
Ooh, I think that was when we decided to not only send our platform errors into it, but all messages. So just turn on info, not even debug, just turn on info. And I think very, very quickly it became clear that, okay, that's not going to work with MySQL anymore. In hindsight, you know what? I think it would have worked with MySQL still if I had known a little more about database design, but I was a very junior developer. Maybe don't write this all into one table. Maybe shard those out a little, split them up by days, be a little more intelligent about it. All stuff Graylog does now, and Graylog started doing very quickly. The moment the use of the application skyrocketed, as in the application Graylog was monitoring, and we turned on info logs, it just broke. No chance. And then, but you know what? Then you fix it and you improve it, and that's how it has always grown back then. You know, it has always grown that way, and I think everything we did always just made sense because it arose from a real use case.
Oh, that's great. And do you remember approximately how many people were there when you left?
At the company I was working at back then, or when I left Graylog?
When you left Graylog.
I think about 120 or so, if you count some of the contractors in, but yeah, about 120 people.
Did you ever imagine it would grow into that when you started out, those early days?
You know, it sounds a little weird, but honestly, yes. Let me explain that. Because it was clear to me that people need this. And if you immediately have people starting to use this without you having to convince people a lot to use this, and you're 21 years old, you know, I think when you're that young, you see more of the opportunities, and I think that you simply haven't experienced all the challenges and the problems and sometimes just bad luck, you know, that can happen on the way. So to be completely honest, yes, I did think that it would grow a lot. Should I have been maybe a little more conservative with that expectation? And now that I'm 36, probably. I think there was a lot of luck involved and a lot of really good people who I met on the way who joined and did some really, really good work, who are a huge part of this success. And I think the reason of this success, honestly. But yeah, I was like, why would it not become big? This is awesome. So, it's like, I'm a very optimistic and positive person. I know this can drive people crazy sometimes, but yeah, honestly, I thought this was going to be awesome.
Oh, that's funny.
And it
Yeah.
was. So a lot of
No,
luck
that's
and good
great.
people.
That's great. It reminds me of, I remember I started my first company right out of university, and me and my friend that I was building it with, I remember us having a conversation about how we were going to handle the growth.
Oh yeah, that's good.
Yeah. But I don't even think we'd finish the UI, and we're already talking about how we're going to handle the growth. Okay, and then a little over a year ago, you started building some really interesting technology and formed a company called Nzyme. Can you tell us a little about what you're building and why it is such a massive improvement for the space in which you're operating?
Yeah. So I hope it will be a massive improvement. That clearly still has to be shown, and I can't wait. Again, I'm very optimistic, so I can't wait to see it. But it's basically I would describe it as a more modern approach to an intrusion detection system, or IDS, where I think you have to assume that most traffic is encrypted anyways, right? This is a little bit into an angle of Wi-Fi and Wi-Fi security, and should you use a public Wi-Fi or not? I think in reality, the absolute majority of traffic today is encrypted, and I think that a lot of the existing IDS systems out there, especially the free ones, were developed in a world and architected in a world where that was not the case, right? Where you could actually you could get a ton of value from looking and inspecting into the packets that are going over the wire. And that comes with a lot of overhead. I think it comes with a lot of different choices when it comes to UI, to how people use this product. And so Nzyme looks at Ethernet and Wi-Fi data, and it derives most detection and analysis opportunities from metadata that is unencrypted. It doesn't, for most things, it doesn't even bother to look into what's in there, because most likely it's going to find some sort of TLS, right? For other things like DNS, like ARP, sure, we'll still inspect what's in it. The moment it goes up the layers, kind of starting from TCP, UDP, it's more and more unlikely that you will find anything that's unencrypted in it. So we will look at the TCP metadata, the UDP metadata, at the IP metadata, what connected where, what was the MAC address, did that change over time? Like all of those things that you can actually derive from, even from encrypted data, or the metadata that's around it. And I believe that network traffic monitoring is not done today in all environments, because it can be extremely expensive, right? It's a ton of data. And the options that are out there appear to be either insanely complex enterprise solutions, and that most companies just can't afford, or previous gen kind of simpler solutions that don't really deliver enough value to justify the spend and the effort, because it's still a lot of data that you got to look at and that you got to store and analyze and pay for. So people, and I feel like that's a little bit of a way out for them. They may say they already have EDR, endpoint detection, so they don't need NDR, network detection. But I think they should actually be able to run both. I think you should have both, because there will always be devices that can't run an EDR agent, or things that can only be detected if you have the full view of the network traffic, and you can correlate in between, which can be tough with EDR approaches. But I understand why today a lot of people don't have NDR. I've seen people try to use SIM systems for NDR, like a Splunk, a Graylog, sending their network data into that. I think it's a terrible idea, because those systems are not designed to store that amount of data in a format and a structure that you would usually store log data in. That's just two very different problems. But often that's the only solution they have, right? That's the only way they have of doing that. And then they will somehow find a way to parse that data, send it into a SIM, pay even more money. And then on top of that, you still have to write all these super complex queries. And so Nzyme wants to do a lot of that stuff out of the box wherever it can, and then forward kind of subsets of that data into something like a Splunk, an OpenSearch, a Graylog, whatever, where you can then derive additional value from it. So that's where it sees itself today. That's, of course, changing. That will be changing based on user feedback, I think, based on what's actually happening out there. But from a broad kind of infrastructure and product idea perspective, that's what it does today. And it does Wi-Fi, and that's what we talk about, I think, a lot today. And that is because it's in alpha stages right now, and the Wi-Fi part is simply the most complete. I started with the Wi-Fi part. The previous versions of Nzyme were only Wi-Fi, but it's important to know that it will do similar things with Ethernet data as well. It's just right now the Wi-Fi part is the most advanced and what people use, because that's honestly the usable thing in Nzyme right now. It's still in the middle of development.
Right. Oh, very interesting. I'm curious how you made the jump from log data to Wi-Fi security.
Yeah, if you spent 13 years parsing arbitrary strings, that can be anything, and you have to build a product that does that. Yeah. That is a very interesting problem, but you are also, once you leave that space and that domain, you are very happy about very clearly defined things to look at. Like, yeah, there's an RFC that defines what TCP looks like. I love that because I can look at that and then parse that. DNS, ARP, UDP, TLS, Wi-Fi frames, all of that. I know exactly what it's going to look like. And if it doesn't look like that, then I will report that. But you can build parsers, and then everyone runs those instead of building parsers that run parsers that can configure other parsers. That was my world before. And I am very glad to now be in the world of very, very, very RFC heavy, fully specified data I will be looking at. Yeah.
That's a wonderful answer, and it makes sense. Is this project open source as well?
It is. It's SSPL licensed. There's a discussion if the SSPL is officially called open source or not. It's basically the GPL, which is clearly open source, but comes with an exception that says you are not allowed to run this as a service. So if you are a Google, Amazon, Microsoft, any sort of service that could go and just take this and offer it to their customers without contributing back, you're not allowed to do that. You would have to then contribute, just like other open source licenses, you would have to contribute your tooling, all the stuff that you wrote to make that service available back to the project. And so that's MongoDB is using that one. There's other open source projects that are using that one. So yeah, it's all on GitHub. You can use it for free. It comes with all the freedoms of other open source licenses, except that exception that you cannot just run it as a service without contributing your code back to it.
Oh, that's a wonderful license. I wasn't aware of that one. It's obviously a little bit newer since I was into open source licensing.
Yeah.
And yeah, because a lot of open source projects, that's how the people who start them make their money, is by turning it into a professional service, and they offer that tier 1 service. And there is a lot of actors that operate in bad faith and will just take projects like that, and Yeah,
that's exactly where this license came from. There was a very popular, huge cloud hoster that just took the things and called it something else and offered it and never contributed back. I mean, the spirit of open source is that, yeah, you can take it and sell it if you want to, right? Yeah. Sure. I mean, fine. But you got to contribute back to the kind of upstream project. And this license enforces that. Yeah.
Oh, that's great. That's great. So I asked you on the show because I wanted to do a bit of a deep dive on Wi-Fi security in general. At the most basic level, Wi-Fi transmits data using radio waves. A device's wireless adapter converts data into a radio signal and sends it out via an antenna. This process works both ways. The router also takes data from the internet, converts it to a radio signal, and sends it back to the device to be coded. In those radio waves, there's data that needs to be transmitted reliably and securely, but before that can happen, you need to discover and connect to a hotspot. How does that process work, and what are the components that make it possible?
Yeah, I could spend probably an entire week talking about how that happens and why I find this so fascinating. So I'm going to keep this on purpose extremely short. The access points make themselves known. So when you open on your laptop, on your phone, wherever you want to connect to a Wi-Fi, I would say on 99% of the devices, you get a list of all the Wi-Fis in range. Right. And if you think about it, how does that device know about these Wi-Fis that are in range that you can maybe potentially connect to? There are two ways of doing that. They basically advertise, the access points are advertising their existence and the networks that they are serving using a beacon frame or a probe response frame, which basically says, hello, I'm an access point. I'm serving these networks with these with these capabilities. So things like I support the following frequencies. I support the following kind of advanced features like fast roaming between access points, all sorts of stuff. And this is the network name, and these are the security settings. So you will need a password to connect to it. You will need your device needs to support certain security features, all of that. And they just broadcast this out entirely. So while you are sitting where you're sitting right now, you are probably, if you had a big antenna on your head and your brain could read these frames, then you would probably get hundreds of these every second because they really blast them out really, really quickly. And so your brain could now build a list of, okay, these are all the networks in range that I'm receiving, right? And that's exactly what your iPhone does. That's exactly what your laptop does. Now, to make that work, and I want to deep dive too much into it because I know your next question is probably going to be about that, but the access points are using a frame type called a management frame. And those are very different from two other frame types, which are control frames, which are used to kind of manage the wireless traffic, as in, I want to send data. Can I send data? And the access point says, yes, you can send data now to avoid collisions on the air. And then also data frames, which is the actual data on the higher up layers that you are actually communicating with when you do something on your endpoint. But the management frames are kind of the ones that are absolutely essential to a functioning Wi-Fi network. And by definition, those have to be unencrypted, because if they were encrypted without doing some sort of certificate exchange before, how would you be able to read these beacon frames that advertise the networks, right? So a lot of this management traffic is unencrypted. And I think with that, I'm going to hand it back to you.
I just had a little flash of a nightmare when you said those frames going into my brain, thinking about Neuralink and all the stuff that's happening there. So the all these management frames being broadcast around are unencrypted, which is where the security issue lies. And that's because they're unencrypted. Anybody could intercept them, modify them, and resend them. Is that basically the flaw in this model?
That's correct. And it kind of is a flaw, but I'm still waiting for someone to come up with a better idea, to be honest, because it's kind of inherent with wireless communications, right? Or with wireless consumer communications, where it's unfeasible to do pre-exchanges of certificates. So if you ever wondered why
this is where convenience causes us problems again, right? Because
we
want to be able to just walk into a room and connect to whatever Wi-Fi is there, and that's the danger. Because
in really high security environments, you can do that. If you have ever connected to the DEF CON conference free Wi-Fi, you have to download the certificate first and install it on your phone, right? So they do that actually. You can do that. It's just not very feasible. But yeah, you're correct. They're not encrypted. So first of all, they can be read by anyone. But that's less of a problem because they don't really contain the higher layer information. So yeah, you're going to read a bunch of management traffic. Fine. I don't really care about that. There's almost nothing interesting in there for if you were looking for to really eavesdrop on someone. The real problem is that they can be spoofed very easily, right? There's no authenticity guaranteed in it. And especially with wireless transmitters, yeah, you can be anywhere. There's not even like the physical verification of, okay, at least this came out of this wall, right? At least this came out of this network jack that I can assume is connected to a legitimate switch somewhere, that is connected to a legitimate infrastructure somewhere, because someone might be on the parking lot with a really big directional antenna and sending these management frames. And there's no real way. Well, Nzyme does a few things, but if you were to spoof them perfectly somehow, which is unlikely, but for most devices out there, there's no way to find out if this is a legitimate frame or not because they're unencrypted. You can spoof every bit of it.
And if I wanted to watch this traffic and possibly send out my own frames, what kind of equipment do I need?
Yeah. So you would need a Wi-Fi adapter. So basically a Wi-Fi card. There's some PCI Express ones, but you will probably want one that's simply USB. It's a little USB stick looking device with often a antenna on it. You'll need one of those that support what's called monitor mode and frame injection. And that basically comes down to the chipset on them. And there's 2 or 3 out there that are really well supported on Linux, and where the where the standard Linux drivers do allow you to do that. Good thing is they're very cheap. You can get them on Amazon for $20. And then there are better ones, and they're like $50. But yeah, you can. That is readily available hardware. I can, whenever I need one real quick. Now I have a box full of them, obviously, but a few years ago when I needed one really quick, you can get them next day with Amazon. They're just going to be in the mail. Wow. No problem. They're very readily available. Mm-hmm.
Wow. I could see the teenage version of myself getting into a lot of trouble with this back then.
Oh yeah. There's going to be antennas everywhere.
So during your talk at Mission Control, you went through a handful of Wi-Fi threats. Can you talk about the man in the middle scenario, how that takes place in a Wi-Fi attack?
Absolutely. So imagine and this is another topic I can talk about for hours. But again, on a high level, imagine someone somehow made your device or devices to connect to their Wi-Fi network. This is like you're plugging your device into somebody else's switch, right? They are now by definition sitting in the middle of your communication because they are routing your communication now. And there is a name for that. It's called a rogue access point or an evil twin access point. There's technically a difference between those two, but I like to use them interchangeably. Basically, it means that someone tricked you or someone tricked someone to connect to their access point when the person connecting believes it's someone else's access point, and most likely a legitimate access point, right? So let's say you are at a coffee shop, let's just say it's Starbucks, and you want to connect to their free Wi-Fi, and there's an implied trust towards that network. Right? There's an implied trust that, Starbucks probably, I don't know, but most likely doesn't set up their Wi-Fi networks to do nefarious things with your traffic, right? Now, let's say somebody else is just outside of Starbucks or in Starbucks or any other coffee shop and sets up a Wi-Fi with the same name. Then technically, this is look for your phone. This is just another access point serving this. And if the signal strength is better, that it's likely that your phone is now going to connect to that one. So the physical properties of a Wi-Fi signal or any radio frequency signal, that it can be limited to a specific environment in most cases, means that it's very easy for someone with this tiny bit of hardware in their backpack to trick you into connecting to their access points. And now they are sitting in the middle of your communication. And with everything man in the middle, there's so much encryption now that the things you can do with it are more and more limited, as in you still can't just spin up a fake website of your bank, right? Your browser is not going to let you do that. You have to very actively ignore 10 different warnings to still log into that with your actual password, right? It's unlikely. But you can still do some things with that. And the act of connecting to someone else's network also opens you up to some things around captive portals, but I believe we're going to talk about that in a bit as well.
Mm-hmm. And I'm just curious, like you mentioned disassociation frames earlier. Mm-hmm. If I was, a bad actor sitting in a coffee shop or at a conference even, and I broadcast some of those disassociation frames to kick people off the network, and then my my evil twin had a stronger signal and was open, would some of those people silently get booted and reconnect to my network without any notification that they had switched networks?
Yep. There is a frame type called the deauthentication or disassociation frame. That one has the legitimate purpose of disconnecting. Either your phone can actively disconnect from a access point and just be a good citizen and say like, hey, I'm disconnecting, I'm leaving. You can take me out of your association table and don't have to wait for a timeout. Or the access point can say, hey, I'm going offline for maintenance. And there's, I think, 60 other reason codes out there. Mm-hmm. Let's say it's for maintenance. I'm going offline for maintenance. Connect to another access point real quick so you don't lose your connection and have to do that. And then there's all sorts of latency issues and connection issues. The problem with that is that's a management frame. And it is in most networks. There is a thing called protected management frames, but they're not very widely used because of compatibility issues. But they are unencrypted in most networks, which means that, you can send those and you can spoof those. And they are also not a request, they're a command. There's no answer to a deauthentication or disassociation frame. It's just your device will just follow that. And that means that I can send deauthentication frames to your device in the coffee shop and say deauthenticate. It will just do that. That's the standard in Wi-Fi. We'll just do that. And then you will most likely, either it might, in most cases, it will reconnect to another access point of the same network, which could be the rogue access point in the backpack, or it will tell you that it disconnected and you pick a new network. And then let's say someone has a rogue access point and called it just free Wi-Fi, right? And you're in a rush, you just need some Wi-Fi right now. You might connect to that one as well. But yeah, it boots you off the network. And this is not a request. This is nothing your phone is going to prompt you. Do you want to leave the network? That just happens. And you're just offline, basically. Yeah.
Yeah, and you mentioned compatibility issues with like newer technology that solves the problem, but the problem with like widely distributed hardware is the change cycle is so slow that it'll take a long time before they can actively use that new technology because everywhere is still using old routers, right?
Yeah, and it's even when your router or your Wi-Fi hardware starts to support, or your access points start to support something like the newer security features like WPA3, protected management frames. Once they do that, now all your devices have to support it as well, right? There's usually no transition modes for most things, so that's either enabled or not. There could be optional PMF or protected management frames, but even that needs to be supported. There's a WPA2 and 3 transition mode, but that really just means it does both, and your device can choose. So you still have it. You still don't. It's now hard to say what actually uses what. It's kind of messy, and it's actually worse than you would think. So I just moved into a new house, and I took that as an opportunity to kind of redesign the entire Wi-Fi network. And of course, I massively overcomplicated it because it was a great learning opportunity as well. So, is there a radius server for 802.1x EAP enterprise authentication to my home Wi-Fi now? Absolutely it is, right? And there's TLS involved, and it's crazy. But my laptop is still connected to WPA3 personal and not enterprise network, because it's really hard to get that work even on the latest Linux distributions. You know, so it's even worse than you would think. And that's why you will mostly see WPA2 out there, maybe with an enterprise authentication, usually just with a pre-shared key where you kind of have the password and connect to it. And so, yeah, it takes a long time for all of those things to catch up. And then some things will never catch up. There's, I don't know, some of your embedded hardware, very unlikely those are going to support any of the new things in their lifetime, right? And so you will still have these SSIDs or networks with less security, and then it's your responsibility to use the underlying network routing and put them in their own VLAN and make sure that they're not as trusted, or can maybe only communicate out directly to the internet but never see anything else on the network. So it turns into a network security exercise really quickly. Yeah. So I have 5 SSIDs at home now for that reason.
I was going to say, I can almost see like a new version of war driving where you're going around looking for the older access points.
Absolutely. And I think so there's wiggle.net, which is very popular for war driving and just captures all of those hotspots out there. There are statistics about how many networks support these newer security features, and it's pretty bad. It's pretty bad. Most don't. And it's usually because of the endpoints, because you can't get the endpoints to support the newer hardware.
Yeah, new things to be terrified every day. That's why I love this industry. Another attack method you talked about was eavesdropping. I suspect it's probably not as bad as it sounds because of all the encryption you talked about, but can you explain how that attack works?
Yep, absolutely. So if you are on a WEP, which is the really old encryption for Wi-Fi communications, which I hope you're not, because it's useless at this point. And I have not seen one in a very long time. Or on WPA1, the encryption key between all clients is shared, which means if you're in the network, you can also read the traffic of everyone else who's in the network. Or if you're on an open network, you can read the traffic of anyone who's on that network, except if you are on, against one of the newer standards. It's OWE, which is the opportunistic wireless encryption, or enhanced open, which apparently a few hotels have started to use. I still have to find one, and I actually have to find one because I want Nzyme to support it, but I just can't find it in the wild anywhere to test it. But basically, that's a open network where you can just join without a passphrase. but it does encrypt your traffic individually, and it does encrypt traffic at all. Open networks don't, which means you can eavesdrop. You can just read those. You can read that network communication, and if the higher layers of the network stack are not encrypted, then yeah, you can see that and you can read that. So there's a lot of DNS, for example, that you will see on that. You might sometimes see, very rare now, but you might see an unencrypted SMTP exchange. But yeah, it's getting, because most people now are almost forced to use encryption on the higher layers. It's very rare. I think that I'm always careful not to overhype the security issues in Wi-Fi, and I personally use public Wi-Fi very regularly. If you want to make sure, you can wrap all of this into a VPN you trust. But yeah, that's eavesdropping, where you can basically, just like if you were wiretapping on an Ethernet line, it's just much easier with a Wi-Fi adapter that supports monitor mode, because you can just sit there and just pick up a lot of traffic. But again, most of that is encrypted. I don't want to open up that discussion right now, but I do actually think that yes, in August in Las Vegas for DEF CON and B-Sides and all the other conferences, you can probably actually use Wi-Fi at the airport and at the coffee shop. It will be fine. Because if not, then you should just never do that anywhere. You'll probably be fine.
Yeah. VPN's not a horrible idea, though. I think that's pretty good practice.
Yeah, and it's so easy to turn on. The good ones that you can probably trust, they're like $2 a month or something. Yeah, just I turn that on one that I do trust, and then you feel a little better. But yeah, it's
and
probably
I'll tether to my
more than
phone
$3
all the time too, if it feels a little uncomfortable. Yeah.
Right. Yep.
So the next one you talked about was the risk associated with someone gaining access to your network by cracking or stealing your password. If that happens, then you just have someone on your network. How do you manage this risk if your Wi-Fi signal covers an area that would be easily accessible to threat actors?
Yeah, I think that one's overlooked because everyone thinks so much about the eavesdropping part. I think one of the real risks out there is that someone breaks into your network through many different ways this is possible, sits in the parking lot and just connects to your Wi-Fi, and through that gets access to the rest of your network and starts to move laterally in the rest of your Ethernet infrastructure, right? The solution to that is pretty straightforward. Not always straightforward to implement, but it's network segmentation, as always. Right? Your guest network should be entirely isolated, of course. That one should only call out to the internet, not see anything left and right, just go straight out and back in, but you can't see anything else of the infrastructure. If you have, let's say you have one of those networks for transition purposes, you simply have some devices that don't support WPA3 enterprise. So you have some that connect to it with a pre-shared key on WPA2, then yeah, those should probably also only connect out directly, and they should probably be client isolated, so never see other clients on the network, on the wireless network as well. They're just all VLANed into their individual network. That's how you solve that problem. Because there are attacks to break into a Wi-Fi, the key might just leak. So think about what happens when someone is in the Wi-Fi. Is there a lateral movement element to other parts of your network infrastructure? And VLAN is usually the answer to that. You want to be, the thing where it gets a little complicated, that was my problem at home in the new house just now, is, well, I still want to be able, so I put the Apple AirPods went into a restricted network, right, where they can only go to the internet, but I still want to play my music in the kitchen, and I want to do that from my phone. I don't want another phone. So it gets a little tricky, right? What communicates to what? You have, maybe you have a TV with AirPlay or something on it in a conference room. You want people from the corporate.
What network is your toothbrush on?
Exactly. You still want people to use that with their work devices, right? So that's where it gets complicated. But I think this is not Wi-Fi specific. This is a network architecture problem that you then get into. Yeah,
sure.
But that's
and I would be really curious to know what the stats are about how many security teams are logging failed passwords into their wireless access points, because I imagine a lot of them aren't, and a matter of cracking the password is just time if there's no mechanism to stop.
Yeah, and for some older protocols in Wi-Fi out there, you can also do that offline. You just collect enough traffic, take that PCAP with you, and then try to break it offline. You don't have to sit in the parking lot for forever with a giant cracking rig. You take that PCAP with you or upload it somewhere in the cloud and crack it there. Yeah, wow. Absolutely.
So I know you're excited to talk about this one. I believe it's one of your favorites. What is a captive portal?
Oh, yeah, I love that one. It's also something people tend to not always think about. Captive portal is, let's say you are in a hotel and you connect to the Wi-Fi, and then somehow this page just pops up and says, enter your room number and your last name, right? And pick our $29.99 enhanced Wi-Fi package for more speed for one night. That is a captive portal. If you want to, you may want to dive deeper into how and why that page actually pops up and how that works, but it gets really messy really quick. A lot of the Wi-Fi stuff gets really messy really quick because of backwards compatibility. It really is messy, but don't want to talk about that now. But that's a captive portal. It's captive because it's literally captive. It just pops up. Or at least when you try to open Google or other popular domain names, and that maybe already tells you how that works under the hood. It will pop up with hey, you got to log into this thing first. And there can be also enterprise use cases for that. Like, hey, you are a guest, but you need a corporate sponsor who actually allows you to be in, right? This is not a guest access for everyone. You need someone who registered you up front as a guest. Things like that. And it's basically a website. It's just a web page. So it renders HTML. It does render JavaScript. And there is tools like Wi-Fi Fisher, for example, which I love and I hate. I don't hate it. Hate is a strong word, but it can be so bad at what it does. I mean, it does in a really great way. Just what it does can be so bad, which is basically it has templates for fake captive portals where it will say, hey, welcome to the coffee shop free Wi-Fi, or welcome to the hotel free Wi-Fi. Enter your, and then it's let's say the hotel chain rewards number to log in. Your let's say it's in an airport lounge. Enter your airline credentials to log in, right? Mm-hmm. This is a very legitimate thing. Then, mm-hmm. I mean, I think you could get me that way. You could totally, I think, fish me that way when it says, hey, connect to your airline lounge Wi-Fi. But yeah, we'll need to know that you're actually a member. And so you have to enter your username and your password. But guess where that form goes? That form goes directly to the attacker. And you just enter your username and your password in plain text. You just send it there. And these captive portals often don't have additional security measures like, hey, this is not TLS. This is not actually United.com, Delta.com, Southwest.com, whatever. Mm-hmm. Right? They have less of that also. And so it's very easy to fish people that way. And I think when people just want Wi-Fi real quick, it's also very easy for people to just, okay, screw it, just do it. This looks real. I am on the real Wi-Fi, right? I feel good about this. Or it could be enter your Facebook or your Google login for our free Wi-Fi, right? You got to give us something and then we give you something, the free mm-hmm. Wi-Fi. And you can get more creative with that and do something in a corporate network. Maybe find out who manages the Wi-Fi, who's the director of IT, and just pop up a captive portal after someone connected to your Wi-Fi because you de-auth them out of the official Wi-Fi, and it says, "Hey, this is the new security measure," and John Doe, the IT security director, implemented this, and you just got to enter your domain username and password to connect now. And,
yeah, even asking somebody for like an email and password. Mm-hmm. You know how often normal people or people who aren't in cybersecurity reuse passwords.
And we are so trained. We're all so trained for this, right? Yeah, I'm in my hotel. I got to enter my room number and my last name. Maybe now they changed it. I have to enter my rewards number and my password. Well, maybe. I love it and I hate it.
Yeah. I see we're at time here. Are you good to keep going?
Yeah, I'm good.
Yeah. Okay, awesome. That's great.
This is the cool thing being the only one in the company. I have no meetings. The next thing is I'm getting a little hungry. So I'm thinking about lunch, but that's it.
Okay, awesome. This is a great conversation. I'm glad we can keep going. So the last thread I have for you is one that I also think I would have really had a good time with as a teenager is jamming. How is this one done, and what is the risk?
Yeah, so jamming is basically interrupting the Wi-Fi communications and making it impossible to use a Wi-Fi. That can be, again, like you said, right? If you're an interested teenager in this, then yeah, it might just be fun, right? It might just be fun to see how no one can connect anymore. It's just playing around with it. Highly illegal, by the way, in the United States, and I think most around the world. They're very strict with these kind of things. This is like, now you're talking FCC territory. Jamming actually, so jamming can be done in two broad ways. I think for Wi-Fi, this is either by jamming the underlying radio frequencies. So you just send a bunch of garbage on the same frequencies, and so the actual signal doesn't make it through anymore. That used to require very special hardware. I think that when I was giving the talk at Mission Control, I was very specific about how specialized the hardware has to be to do that, and especially do that at scale and over a broader distance. I have now seen that there is firmware coming out for popular chipsets, especially the one on the Raspberry Pi, that somehow can do this. And I haven't looked into this too deeply yet, but can do the RF level jamming on standard hardware somehow. So they somehow figured out how to make that chip send a bunch of garbage on the air and use it almost like a software-defined radio, which is a little scary. I have to look into that. So that is also, even that is changing. But that will be, the problem with that is that will be really hard to detect without special hardware, because if you try to detect that kind of jamming with a Wi-Fi adapter monitor mode, because it's just garbage signals, they're not even going to make it to you. The chip in the Wi-Fi adapter is going to discard that immediately as noise, basically. So you're not even going to see that. That's going to be an interesting problem. The other way of doing that, which is much easier, is you just send a bunch of deauthentication frames to everyone. There's also a funny thing called the broadcast deauthentication frame, which basically means everyone disconnect from everything. So yeah, jamming. You can do that. That is, of course, something where if you want to interrupt something, right? Let's say you want to, I've heard about some scenarios. I've not heard about this happen in the real world, but there are scenarios about you want to, as part of a larger hacking campaign, if you want to sow as much confusion as possible, you also have someone physically on site who starts to disconnect and jam the entire Wi-Fi of a system, right, of a building. So let's say it's a company that has all of their security people on site, might be a high security environment, and you start a campaign against them, and you start to break into systems. Now, if you want to make their response, if you want to slow down their response, yeah, you just stop the entire Wi-Fi, right? People can't use their phones anymore suddenly, not over Wi-Fi at least. Maybe some systems that are Wi-Fi connected suddenly don't work anymore. Maybe your door scanners, so people can actually get into the SOC, right? Maybe people can come to work. You disable the door scanners if they're Wi-Fi connected. There are some interesting scenarios on that. But I haven't heard about that in the real world yet. But it's an interesting thing to keep in mind, I think.
Yeah, for
in the worst
sure.
case, it's someone at a cybersecurity conference who has one of those jammers and just messes with it, and everyone has a bad time, right? Because now the presenter can get to their slides that might be on, I don't know, Google Slides or something, or other equipment doesn't work anymore. Because you can get those jammers that you literally just press a button and they disconnect everything automatically for like $10 on Amazon. And they're really annoying because you can't really do much about them except to physically apprehend the person who does it. Yeah. Which is where Nzyme is coming in, because Nzyme, I'm working on that functionality right now, can show you on a floor plan the source of these signals. And now it starts to become interesting, because that's the other big question in all of this. How do you respond to Wi-Fi security alerts? What are you even going to do? Right? Now there's a physical security angle in this. How do you respond to someone who's on the parking lot with a big directional antenna? And how do you know where that is? And what do you do about it? It's another very interesting angle in all of this.
Yeah, and I don't want to give away too much if you're not talking about it, but these are the taps that you're building, right?
Yes. So the reference architecture is on a Raspberry Pi, but you'll really be able to use anything that runs Linux. And the taps are a component of the Nzyme architecture, and they basically collect all that data. They use one of those Wi-Fi adapters or multiple of those Wi-Fi adapters in monitor mode, and they just basically sniff all the traffic on the air, all the management frames, never the actual data frames, but the management and control frames, and then uses that to find out if there's anything security relevant going on the Wi-Fi. And yeah, it can triangulate. If you have more than 3 of those taps or sensors, and they are spread out enough physically on the location, then Nzyme can calculate where that signal is likely coming from, at least give you an approximation, right? It will be able to tell you, yeah, that's coming from a parking lot, and that's coming from your north parking lot, for example. Right. It will be able to tell you that.
Yeah. Have you done field testing? Do you know what the minimum distance is before you can start to get useful data and stuff like that?
I have. I'm not comfortable enough yet to to say that. I am about to deploy a bunch of these tabs with this new functionality that's coming now, and that will get some real world testing. And I'm always the first to just put the initial results out the moment I feel like I can trust them. So there's on the Nzyme Twitter, Mastodon, website, blog. There's going to be a bunch of content about this coming for sure, because I love to share this kind of stuff, and it looks really good because it's a heat map on a floor plan. It looks very good.
Very cool. If anybody's listening and wants to learn more and get involved, I'm not sure what kind of stuff you need help with, but it's open source. What should they do? Like, and are you selling hardware? What kind of guidance is there?
Absolutely. Yeah, install it and try it out. That is the absolute best thing if you want to help with this. Because I worked really hard to make it super easy to install and maintain. So most of the people who installed it, which is several hundred by now, gave me the feedback that this is ridiculously easy to run and maintain and to set up. And so, for example, it comes with an entire certificate management UI, because I don't want people to mess around with the OpenSSH, OpenSSL CLI to convert their certificates in the right way, then put them all in the nodes in the right location, restart the server, hope it works. No, you just upload it in the web interface. It will convert it to what it needs to be, and then also previews it before you install it, and then just does it for you. You don't even have to restart Nzyme for it. That's kind of the approach in general. I think something I learned from building Graylog and getting 13 years of feedback from people, everything where people always got stuck at, I tried to make extremely easy for Nzyme. So what I'm trying to say is, give it a try. It won't take a lot of your time. It will be really easy to install, and it's not going to be frustrating. If it is, please let me know, because then there's another thing that needs to be improved or fixed. But I am really looking for people running it, and then running it in all sorts of different environments and telling you what's missing, what's not working as well, or like I said, where they get stuck or they get frustrated, because I want this to be easy in all the common environments. And you can, of course, also contribute code. But I would say the developer experience is just not very polished yet, because again, this is only me working on it now. So there's not a lot of documents explaining the architecture of the code, how to build something custom, all of that. So you'd have to spend some time to start to understand how the code works internally and the architecture. But some have done that already, and they were successful. And there have been several PRs that have been merged by now. But if you just want to help out with the project, run it, and then tell me about it and tell the world about it. I think it's one of the best things that you can do, and that I'm looking for the most right now.
Very cool. And I'll put all the links in the show notes for anybody listening.
Awesome.
I also want to add, too, that now you can run LimaCharlie's EDR on those Raspberry Pis for, I think, Raspberry Pi 4 and up, so on the 64-bit Pis. So you can have an EDR protecting your network defense system.
That's going to be awesome.
It is. I'm going to have to order some more Pis. I think I have too many 3s kicking around my house. So.
Oh, yeah, I got some if you need some.
Okay, this is the last one I have for you. It's the one I ask of everybody on the show. It can be as wide or as narrow as you want. Do you have any predictions for the future of cybersecurity?
Yeah. So I try not to, because I am personally in such a niche spot of security. I think there's people out there, a bunch of people that work at LimaCharlie actually come to mind, that have such a broad insight into the entire industry, right? That I just honestly don't have. Mine would be very broad, and I think for other parts of the industry, very high level. But I think it's safe to say that it probably won't get any easier, and there probably won't be any less challenges, right? And I think there's some real threats, and what I'm thinking about is not only to specific computer systems or specific types of data, but I think we're seeing more and more now. For a while, we see more and more, but they're real threats for societies, right? For like our daily life that is so interconnected and that is so much relying on infrastructure. I think we've seen that with elections, with misinformation, with some of the recent conflicts that broke out, and how much cyber is a real domain in that now. And I think people have been talking about this for a long time. I feel like over the last 2024, over the last 10 years or so, this has become all those predictions have actually become very real, and for me personally, more real than I had expected them to be. And so I think, or I hope that we, as the people who defend, and that surely includes people who are on the red team side as well, right? Because I think they're a huge part of the defense of it. So everyone who works in this space and has good intentions, who I would describe as people who defend, that we can all keep on building real solutions to those problems. And the word real is important for me in that. I think that's things that is always a good indicator, something that at the end of the day, when we leave the office, things that we are proud of and things that we like to talk about. This is why when you asked me if I can come on the show, I said, oh, would love to, because I am actually really proud of this stuff and I really believe in it. And I believe that this is not something that's kind of just shiny or artificially pumped up, but this is one of those things that are actually real and I believe will really help with the defense out there of things. And I hope that we as an industry, we can keep on doing that. And there's so much of that stuff that's going on right now that makes me, again, optimistic and hopeful about it. And I hope that we all can, with the changes the world is going through and with the changes that economies and markets are going through, that we can keep on doing that, and that we all produce a ton of stuff that is real and that helps to defend kind of our lives in the end. You know, this sounds a little dramatic, but in the end, that's what it comes down to. And somebody has to do it. And I love that we can do it. And most of us enjoy doing it, which is kind of like the perfect storm, right? Mm-hmm. This is not some things that we actually don't enjoy and that, somebody has to do it and we actually hate it. It's a great combination if you actually love doing it. And I think that's when really good products come out and things that provide real value out there for, I think, a really good cause in the end. That's not really a prediction. It's more of a hope. But I feel like, again, we're in a good way, and I hope we can keep on doing that.
One of my favorite answers so far, and I couldn't agree with you more. Yeah. Thank you so much for being on the show with me today, Lennart. This is by far one of my favorite conversations so far, and awesome. I think it provides a lot of value for our listeners. So thanks again.
That's fantastic. Thank you so much. That was fun.